Welcome to 10th class math chapters. Let's learn mensuration in this video. Mensuration is the study of areas and volumes of the shapes, different shapes, which we often see in the real life. Okay. So in this chapter, what we learn is introduction, surface area combinations of solids, volume combination of solids, conversion of solids from one shape to another, and then exercises. Okay, there is not much theory in this chapter. You have to learn some formulae for calculation of area and volume, and then use them for the problems. That's all is here. Okay, less you don't have too many theorems. No, actually, not too many. There is no theorem basically. Okay, you have very basic chapter. So learn it well. You can't go wrong in this chapter. You should get 100% in these problems. Okay, let's do introduction first. As I said, there is not much theory in this chapter. There are no theorems. There are no proofs and all. What you have to do is just learn some formulae and real life problems. That's all. Okay. If you see the situations here, quantity of water inside a bottle, number of bags inside a lorry, okay, number of matchsticks that can be put in a matchbox, all these kind of things we can solve using this chapter. And you can find areas, surface areas, and volumes of such things, okay, real life things. So first, most important thing is learn the formula, okay, so of the each different shape basically. And you have two kinds of areas, lateral or curved surface area, then total surface area. Okay, what is total surface area? Which is clear. If you are given a shape, complete area on the shape is the total surface area. Okay, and what is lateral or curved surface area? This is only not including top and bottom. Okay, if you don't include top and bottom, that's what you will get. Okay, so if you take a cuboid, okay, of length, breadth, and height, okay, lateral or curved surface area is only 2h into L plus B. Okay, it is important to know how this value is coming. Okay, then you can calculate any given shape. Okay, if you see here, I am not, we should not include bottom and top. Okay, so let's take this facing towards us. Okay, this is L into H, correct? Length into H. This area of this is a rectangle, and we have two opposite side also one more, so two into LH. Okay, plus from the side you have B into H. Both sides 2B into H. So this will become LH, L plus B into 2H. Okay. Total surface area is obvious, very straightforward. You will have all the areas included. Each one is two times because both opposite sides is same. So 2 times LB plus BH plus HL. Volume of cuboid is L into B into H. Okay, length into breadth into height. Cube, if you take all sides are same, so it's very easy. You will have four faces on the side. Okay, not top and bottom if you remove four faces. So 4 into A square is lateral surface area. Total surface area is 6A square and A cube. Okay. Similarly, learn all these shapes. Okay. Uh, yeah, for the pyramid, what is written is height. Okay. This is called height. Okay. Height is from the peak point to the center of the base. This is height. Okay. And what is this height? This is a slant height. Okay. This is a slant height. How do you calculate the slant height? You just apply Pythagoras theorem because it will form a right angle triangle with the height and half of the uh, uh, breadth or length here. Okay. So it will form a right angle triangle. So with that you can get a slant height. Okay, this is called slant height. Okay, so for right pyramid, lateral or curved surface area is half of perimeter of the base into slant height. Okay, and lateral surface area plus area of the base, that is total surface area. Okay, one third of the, this is a cone structure, right? So almost one third of area of base into height. Okay, so same thing for the cone. Okay, and then you have a sphere and hemisphere. Sphere is a complete sphere and hemisphere is half of it. Okay, so lateral surface area is exactly half, but whereas curved surface, I mean total surface area, you will include the top pi r square also. So it will become 3 pi r square. Okay. So these things you remember. Now let's get into examples. With that, you will learn more actually. Okay. The radius of conical tent is 7 meters. The radius is 7 meters and its height is 10 meters. Calculate the length of the canvas used to make the tent. Okay. Now, what is the length of the canvas? Okay. Length of the canvas is the total surface area. I mean, a lateral curved surface area of this tent. Okay. Because bottom you don't need to have any uh, cloth, right? So, radius of the tent is 7 meters. Height is this one. Slant height is what we require. Slant height is nothing but Pythagoras theorem applying here. So, I get this slant height, which is nothing but 12.2 meters. So, surface area of the tent is pi r L. Okay. Pi r L. Okay. So, which is nothing but this value 268.4 meters square. This is the value. Okay. Okay. Now, this is the canvas used, and given that width of the canvas is 2 meters, width of the canvas is 2 meters. So, length into width is this much area, right? So, length used is basically area by width, which is nothing but 134.2 meters. This is the length of the canvas which is required to make this tent. Okay, next. An oil drum is in the shape of a cylinder, okay, having the following dimensions. Diameter is 2 meters. This is 2 meters. Height is 7 meters. The painter charges 3 rupees 3 per meter square to paint the drum. Okay, find the total charges to be paid to the painter for the drum. Okay, given this is the diameter, so radius is 1 meter. Okay, total surface area is what we require here because paint is to the complete drum. Correct? Is nothing but 2 pi r or pi r 2 pi r square. That pi r square on the top, pi r square on the bottom, 2 pi r square plus pi 2 pi r h. Okay, 2 pi r is the uh, if I expand this cylinder into a rectangle structure, I'll get the length as 2 pi r and height is h, so 2 pi r h. So from that we derive this equation basically, right? So you should know how to derive equations actually for this chapter. That is more important than solving these problems. Okay. Now you substitute values, you will get the answer. It's a straightforward. So this is the area required to be painted. Now cost of it is per meter square. It is 3 rupees. So total cost for one drum, 10 drums basically is asking is this into 10. Okay. This into 10. Okay. Which is nothing but 1508 rupees 40 paise. Next. A spherical cylinder a sphere, cylinder, and a cone are of the same radius and same height. Find the ratio of their curved surface areas. Okay, this is very good problem. There is no numbers given if you see. Okay, so sphere, uh, cylinder, and cone are same radius and same height. Okay, so if you call this h, height is h, cylinder height also h. But what is h? H is nothing but 2r because height of sphere is nothing but diameter. So diameter is nothing but 2r, correct? So height of the cone equal to height of the cylinder equal to height of the sphere, which is 2r. Okay. Now slant height of the cone is this one. Okay. If I simplify, I'll get square root of 5r. Okay. So first is curved surface area of the sphere, which is 4 pi r square. Curved surface area of the cylinder is 2 pi r h. Okay. 2 pi r into 2r. Curved surface area of the cone is pi RL, which is nothing but root 5 square root of 5 pi r square. Okay. So the ratios are 4 is to 4 is to square root of 5. This is the answer. Okay. Next. A company wants to manufacture 1000 hemispherical basins from a thick steel sheet. Okay. If the radius of each basin is 21 centimeters, Radius of each basin, this is radius, or this is radius, is 21 centimeters. Find the area of the steel sheet required to manufacture the above hemispherical basins. It's a basin, so obviously you will have top open, right? It's not closed. So radius of the hemispherical basin is 21. Surface area of the basin is 2 pi r square. So this is 1. Okay. This is 1. And I want to make it 1000. So into 1000. Okay. Required for 1000 basins is into 1000. Which is nothing but if I convert into meter square. Okay. The value. And another important point in mensuration is check the units carefully. Okay. This is the only place where you can go wrong. Okay. If the units are different, first convert them into same unit and then do the operations. Okay. So units is one place where you can go wrong in this mensuration. Other than that, if you remember the formula, you can just apply it very easy. If you don't remember the formula, you should know how to derive a formula for each shape. Okay. It's very easy. It is not a big thing. Okay. Example 5. Right circular cylinder has a base radius 14 centimeters and height 21 centimeters. Okay, radius is 14 and height is 21. Okay, find following things. Area of the base, which is simple. Area of the base is nothing but pi r square. Okay, you apply the values. Then so curved surface area is 2 pi r into h. Okay, 2 pi r is this perimeter. Okay, which if I stretch this cylinder into a rectangle shape, 2 pi r is my length into h, correct? So curved surface area is 2 pi r h. Substitute the values again. Total surface area is 2 pi r h plus 2 pi r square of the base and top. Volume of the right circular cylinder, which is nothing but cross section area, which is pi r square into height. So pi r square h. So these are the four formulas you will apply to get the values. That's it. Okay. So these are the values. Each one is given here. Okay. Find the volume of the surface volume and surface area of sphere of radius 2.1 centimeters. Okay. Radius is given here 2.1. So surface area is 4 pi r square. So you'll substitute volume is 4 by 3 pi r cube. Again, substitute the values, you'll get it's a straightforward. Okay. Don't do calculation mistakes. Be careful. And normally, if it is not mentioned, you should put all the decimal points, but if it is mentioned up to 2 decimal points, you round it to the 2 decimal points. Okay, next. Find the volume and total surface area of the hemisphere of radius, this one. Okay, for a hemisphere, volume is half of sphere, which is 2 by 3 pi r cube, correct? And total surface area is 3 pi r square. So you substitute the values, you'll get it. Okay, and do the calculation correctly. That's it. Okay, let's go to example, exercise 10.1 now. Let's do exercise 10.1. A joker's cap is in the form of right circular cone whose base radius is 7 centimeters and height is 24 centimeters. Find the area of the sheet required to make the 10 such caps. Okay, so by looking at we can tell this is a cone, right? And what we are looking is the surface area, total surface area of the, I mean, uh, slant lateral surface area of the cone. Okay, so that is what we require and we need to calculate for 10 caps. Okay, it's in the form of a cone. And area required on the cap is lateral surface area of the cone or curved surface area, which is pi r L. L is the slant height. We need to just calculate the slant height. Okay. So given that R is 7 and H is 24, so L, which is slant height, is nothing but 25 centimeters. So surface area of one cap, lateral surface area of one cap is 550 centimeters square. For 10 of them, it is 5500 centimeters square. So that's the answer. Okay. Thank you. Next. A sports company was ordered to prepare 100 paper cylinders for packing shuttlecocks. The required dimension of the cylinders are 35 centimeters length or height and its radius is 7 centimeters. Find the required area of the required area of thick paper sheet needed for 100 cylinders. Okay. Yeah, this is a cylinder, we know, and what we are looking is to cover the total surface area. Okay, because we will have a cylinder and then two caps on the base and height, right? Top and bottom. Okay, so H is 35, radius is 7, total surface area is 2 pi r h plus 2 pi r square. Okay, once you know this, substitute the values you will get, and this is for one cylinder is this much. So for 100 such cylinders, paper cylinder, how much you require is 1,84,800 centimeter square. You can convert into meter square, but yeah, this is the answer. Next, find the volume of right circular cone with radius 6 centimeters and height 7 centimeters. Okay, radius is 6, height is 7. Okay, so radius is 6, height is 7. So volume of right circular cone is 1 by 3 pi r square h. So straightforward, you just substitute the values, you'll get it is 264 centimeter square, centimeter cube, sorry, volume, right? Yeah, be careful with the units. Curved surface area of cylinder is equal to the curved surface area of the cone. Okay. If the radii of both of their bases are same, find the ratio of height of the cylinder to the slant height of the cone. Okay. Curved surface area of cylinder and uh, area of cone are same. Cylinder it is 2 pi r h, cone it is pi r l. Okay. Both have same radius, so r r, and we need to find out height h by l we need to find out. Okay, so 2h equal to this one, h by l is equal to 1 by 2. Okay, next. A self-help group wants to manufacture Joker's cap of, we have seen the same problem before, similar. Joker caps of 3 centimeters radius and 4 centimeters height. If the available paper sheet is 1000 centimeters square, how many caps can be manufactured from the paper sheet? Okay, it's a Joker cap. Okay, cap is always open at the bottom, right? It's a cone shape, but cone open. So what we are looking is only curved surface area, right? Is lateral surface area of the cone, which is pi RL. R is given as 3 and H is 4. Okay, so lateral slant height is 5 centimeters. So what I am looking is the lateral surface area of 1 is pi RL, which is nothing but 330 by 7 centimeter square. I need 1000 of such things, so this is the value. So you can simplify it. Okay, you will get around 21. 21 such caps you can make. Next. A cylinder and cone have bases equal radii and are of equal height. Okay, show that their volumes are in the ratio of 3 is to 1. Okay, this is simple, just a formula substitute. Okay, volume of cylinder is pi r square h and the volume of cone is 1 by 3 pi r square h. Okay, both radius and height are same, so I'm taking same alphabets here. Ratio of those two is, you can clearly see they are in 3 is to 1 ratio, right? This is 3 times volume of a cone. Next. Shape of a solid iron rod is cylindrical. Its height is 11 centimeters and base is 7 centimeters. Then find the total volume of 50 such rods. Okay. H is 11, radius is 7 by 2, which is 3.5. Volume of a iron rod is, it's in the cylindrical form, right? So pi r square H. Okay. If I substitute values, this is what I will get. And we need 50 such rods. So 50 of such one is 21,175 centimeter cube. Next. A heap of rice is in the form of a cone of diameter 12 meters and height 8 meters. Find its volume. How much canvas cloth is required to cover the heap? Okay. So first thing is, let's find out volume. Okay, radius is 6 meters because diameter is 12. Height is 8 meters. Volume is nothing but 301.71 meter cube. Now to cover this hoop, I need to calculate the curved surface area because I need to have, it's like a cone and I opening at the bottom, right? So lateral surface area is this one, so which is nothing but pi r L. L I have to calculate slant height. So what I will get is 188.4 meter square. This much canvas is required to cover this heap. Okay, next. Curved surface area of a cone is 4070 centimeters square. Okay, square this is, and diameter of its base is 70 centimeters. What is its slant height? Okay, so obviously it's a straightforward. Pi RL is given. Okay, R is nothing but 35. Okay, if I substitute values, I get the value of L, which is nothing but 37 centimeters. Okay, so most of these questions are very simple. You just need to substitute the formula, remember the right formula, imagine the right object for the given question, and then just apply the formula. That's it. Okay, yeah. Let's see this next chapter, next topic. Yeah, surface area of combination of solids. Okay, this is nothing but you have multiple shapes, and how do you calculate the surface area of this combined solids? Okay, example which you see in real life is like ice cream cone. This is a cone, correct? This is a cone here, and this is a cone, and you have a hemisphere on the top, right? This is a hemisphere, and this is a cone. This is a bottom one is a cone. Okay. Similarly, if you see the tanker, okay, this is a cuboid or a cylinder, okay, and it is attached on the two ends with a hemisphere, correct? So like this, you can calculate. I mean, you can get many such questions. So if you want to calculate the new hemisphere total surface area, okay, total surface area of the new solid is, okay, curved surface area of the hemisphere, because we cannot count this top and bottom of this cylinder surface areas, okay, base and height, base and top, okay, plus curved surface area of the hemisphere and curved surface area of the hemisphere. Okay, so you have two curved surface area of these hemispheres and then one cylinder curved surface area. So this is how we should calculate. Now, there is one question here. Sanya prepared a toy. She mounted a cone on a cylinder. Cone on a cylinder like this, okay? Whose circular radii are the same as shown in the figure. Okay. She told Archana that the total surface area of the toy is sum of total surface area of the cone and cylinder. Do you agree with this? Think about it. What is that missing one? Okay. Missing one is whenever you are combining two solids and calculating the surface area, there is some surface area which will miss actually. Okay. Some surface area will be always missing. So you should recalculate. In this case, the top cross section area, okay, and base area of the cone, both are actually attached, both are gone from the total surface area of combined objects, right? So this is one example, and this is same for most of the almost all the objects. If you are calculating the total surface area, their total surface areas are not summed up. Okay, you have to subtract something, otherwise they cannot be attached. Okay, they'll be detached. Whereas volumes, if you think of volume is sum of those two actually. Okay, volumes will always sum up when you add two objects, but total surface area don't add up. Okay, some area surface area gets vanished, or what you call, when you attach those two objects, something gets subtracted also. Okay, that's the one. In this case, total surface area of this cone, okay, remove the bottom, okay, remove the bottom, and remove the only take only the curved surface area of this hemisphere, and add, that is curved surface area of both these objects is total surface area of the toy. Okay, so total surface area of the toy is curved surface area of the hemisphere and curved surface area of the CSA of the cone. Okay, So this is a straightforward question which you can do it yourself. Let's see some examples here. Kaushik got a playing top as his birthday present, which surprisingly had no color on it. He wanted to color it with the crayons. The top of shape is like a cone, okay, surmounted by a hemisphere. The entire top is 5 centimeters, as shown here. Total height is 5 centimeters, and the diameter of the top is 3.5. Okay, find the area of he has to color. How much area he has to color? Okay, so this is simple. This top is exactly like an object that is combination of cone and hemisphere. Correct? It's a cone and hemisphere. So total surface area of the toy is CSA of the hemisphere and CSA of the cone, which is nothing but CSA of the hemisphere is half of that of a sphere. Correct? So that is nothing but 2 pi r square. Okay, and yeah, you can see here. You can calculate in terms of this one. The height of the cone and the height of the top is minus height of the hemisphere, correct? And how much is the height of the hemisphere? Hemisphere height is nothing but its radius height, which is 3.5 by 2. So if I subtract 5 minus 3.5 by 2, I'll get 3.325. This is the height of the cone, okay? Now from this slant height, I can calculate, which is nothing but 3.7 centimeters. Once I know the slant height, the CSA curved surface area is pi RL. If I substitute the values, I get the value. And if I sum up those two CSAs, I'll get the CSA of this object. Okay, toy. That is how we will do. Okay, most of the problems. A wooden toy rocket is in the shape of a cone mounted on a cylinder as shown in the figure here. Okay, you can see here, right? Okay, the base of the information given is the height of the rocket, entire height of the rocket is 26 centimeters, while the height of the conical part is 6 centimeters. Okay, this is 6, this is 26, so obviously height of the cylinder is 20. Okay, now there are two kinds of this circular things. The base of the conical position is a diameter of 5 centimeters, while the base diameter of the cylindrical portion is 3 centimeters. Okay, so now you have all the data. Okay, just to substitute properly. Okay, for total surface area of the cone, you need a lateral height, which is calculating here. Okay, which is 6.5. Now you substitute all the values, and something is missing. What is that missing? One of the in the total surface area calculation, one of the either I mean you have the bottom surface area covered, but there is no top surface area. This should be subtracted. Okay, so plus pi r square minus pi r square. That's what is doing this way. Okay, so with that you will get the values, answers if you substitute the value correctly, and then curved surface area of the cylinder you can calculate. Okay, and the area of the base, only one base, right? So, sub let's do exercise 10.2. Okay, a toy is in the form of a cone mounted on a hemisphere of the same diameter. The diameter of the base and the height of the cone are 6 centimeters and 4 centimeters respectively. Determine the surface area of the toy. Okay. Yeah, we have seen example of this problem. It's same. Toy surface area is cone lateral surface area plus lateral surface area of the hemisphere. Right? So radius of cone equal to radius of hemisphere, which is equal to 3 centimeters. Height of the cone is 4 centimeters. Now slant height of the cone is 5 centimeters from the formula, right? So cone lateral area is around 47.1 centimeter square. Hemisphere lateral or curved surface area is around 56.52. Okay, so total surface area of the toy is around 103.62 centimeter square. Okay, so as I said, this is completely about remembering the equations properly. Okay, and imagine the new image formed. If it is surface area, be careful because some values will go off. Okay, if it is volumes, you just need to add nothing else. Okay, next. A solid is in the form of a right circular cylinder with a hemisphere at one end and a cone on the other end. Okay, the radius of the common base is 8 centimeters. Heights of the cylinder and the conical portions is 10 centimeters and 6 centimeters. Okay, find the total surface area of the solid. Yeah, this is easy. Common radius is 8. Height of cone. So slant height of the cone is around 10 centimeters. Lateral surface area of the cone is pi RL. So you get this value. Height of the cylinder is 10 centimeters. And we know the radius already. So curved surface area of the cylinder is pi r square 2 pi r h. Okay. H is H2 here. Okay. This is H2. Okay. So the value is around 502.4. Curved surface area of the hemisphere is 2 pi r square. So that's this value. Now total surface area of the solid is sum of all this. Okay. So this is the value. 1155.52 centimeter square. Next. A medicine capsule is in the shape of a cylinder with the two hemispheres struck to each of its ends. Okay. Like this. Okay. Here and here. The length of the capsule is 14 mm. Thickness is 5 mm. Okay. Find its surface area. Okay. Yeah. Common radius is 5 by 2 mm because this is the diameter. Thickness is diameter, right? So 5 by 2 mm. Okay. Length of capsule is 14 mm. This includes radius, height at both ends. Okay. Here hemisphere. This height also included in this 14. Okay. Which is nothing but radius height plus radius height, that is 2 radius, that is 5 mm, right? Diameter height basically 5 mm. So height of the cylinder is 14 minus 2 into 5 by 2, which is 5. So 9 mm is the height of the cylinder. Now once you know this, total surface area of the capsule is 2 times the curved surface area of hemisphere plus curved surface area of the cylinder. Now each one you substitute the formula 2 pi r square and 2 pi r h. You'll get the values. Okay, 220 mm square. This is the total surface area of the capsule. Okay, next. Two cubes, each of volume 64 centimeter cube, are joined end to end together. Okay, find the surface area of the resulting cuboid. So here instead of giving the edge of the cube, okay, he has given volume of the cube, each cube. Okay, so it is joined like this. So one face is gone basically. One face from each cube is gone. So in calculation of total surface area, it is not 12, it will be 10. Okay, two are gone, right? Two surface areas, two face areas are gone basically. Okay, so volume of each cuboid is 64 centimeter cube, which is a cube. So side is 4 centimeters. Once you know that, okay, total sides open are only 10. So total surface area equal to 10 times a square, which is 160 centimeter square. Okay, next. Water tank consists of a circular cylinder with a hemisphere on either end. Okay. If the external diameter of the cylinder is 1.4 meters and its length is 8 meters, okay, find the cost of painting it on the outside at a rate of 20 rupees per meter square. This is meter square. Okay. Common radius is 0.7 meters. Length of the tank is 8 meters. Total surface area, we know two curved surface areas, two times, and the curved surface area of the cylinder. Okay, if I calculate directly, this is the value I will get. Okay. Now cost of the paint at rupees 20 per meter square. So multiply with 20, what you will get is rupees 872.2. Next. Sphere, cylinder and cone have same radius and same height. Find the ratio of their volumes. I think we have seen similar problem in the examples. It's same. Height of the cone and cylinder is 2 times the radius of the sphere, right? Because it's the diameter uh, height. Sphere is the diameter height basically. So if you find the ratios, they are in the ratio of 2 is to 3 is to 1. You substitute the um, formula correct and in the same order: sphere, cylinder, and cone. Okay, sphere, cylinder, cone. Okay, next. A hemisphere is cut out from one face of cubical wooden block such that diameter of the hemisphere is equal to the side of the cube. Okay, determine the total surface area of the remaining solid. Okay, it's like this. Hemisphere is cut out of one uh, one face of the cube. Okay, so let the edge of the cube is L. Okay, let's take it as L. Radius of hemisphere equal to L by 2. Correct. When a hemisphere is cut out as shown, curved surface area of the hemisphere is added to the base surface area. Correct. And area of hemisphere base is removed basically. Okay. Base surface area of the hemisphere is removed. This pi r square is removed, but 2 pi r square is added. Okay. So surface area of the remaining solid equal to cube surface area plus curved surface area of the hemisphere minus base surface area of the hemisphere, because it is replaced in that area, right? So which is nothing but 6 L square plus 2 pi L by 2 whole square minus pi L by 2 whole square, which is L square plus L square into 6 plus pi by 4. Okay, this is the value you'll get. Okay, yeah, next. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder. Okay, as shown in the figure, like this. Okay, both ends there is a hemisphere scooped out. If the height of the cylinder is 10 centimeters and its radius at the base is 3.5 centimeters, find the total surface area. This is same as the previous problem. Only thing is you need to apply it on the both ends. That's all. So height of the cylinder, radius of the cylinder base. Okay, surface area of article is total surface area of cylinder plus 2 times curved surface area of hemisphere minus base surface area of the hemisphere. Okay. So if I just write the formula here, you will get it like this: 2 pi r square plus 2 pi r h, okay, plus 2 times 2 pi r square minus pi r square, which is pi r square. So finally it will become this value if I take it common. So it's very easy now. Once you substitute the values, you will get 374 centimeter square. Okay. So all the problems here are easy. I think you should not go wrong in the writing formula as well as calculation. These are the two things we should take care. Then everything is very easy in this chapter. Okay. Yeah. Let's do volume of combination of solids. Okay. If you take two solids, multiple solids, basically combine them, what will be the effect on volume? That's what we'll see. Let's learn the volume of combination of solids. Okay. So above we learned last section we learned that how to combine two different solids and what will happen to the total surface area or the surface area. Okay. Now we know that surface. I mean, when you combine two solids, surface area is not exactly the sum of both solids. Okay, individual solids. Some part of it will be covered, so we should subtract it. But in case of volumes, it is fairly simple. Okay. Normally, when you combine two solids, you get the volume, uh, sum of the volumes of individual solids as the combined volume. Okay. So, yeah, I think there is an example given. It's not very, it's not required. It's very straightforward. You can understand. You have one cuboid and then a hemispherical object on the top, right? Half, you can call half cylinder or, yeah, hemispherical, this one, right? So the volume of this final solid will be combined of these two. Okay. So volume of cuboid plus half of volume of cylinder. If you consider the above one, it's a half of cylinder, right? It's cut basically cut into half, right? So half of volume of cylinder. So like that we will do. Let's see this one. Let's check this try section. Try this section. Yeah, that's true. If the diameter of the cross section of a wire is decreased by 5%, by what percentage should the length be increased so that volume remains the same? Okay. Diameter of cross section of wire is decreased by 5%. Okay. If diameter is decreased by 5%, obviously radius also decreased by 5%. Correct. So this is the volume of the cylinder pi r square h. Okay. Now diameter is decreased by 5%, so radius also the same. So volume of the new cylinder is pi 95 by 100, 5% reduced, right? So it is 95 by 100 r whole square h, new h. Okay. We need to calculate this new h, and the volume will remain same, correct? So if I equate both of them, what I will get the new h as h by 0.95 whole square. Okay. So this is the new height. So you understood what kind of problems can come in combination of volumes of solids. Okay. The percentage increase, how do you calculate? Always difference by original. So that's what I'm doing. So it's around 11 percentage change in the height or length. Okay. Next. Surface areas of sphere and cube are equal. Then find the ratios of their volumes. Okay. Surface area of sphere, that is, this is the surface area of the sphere. Okay. And surface area of the cube. Okay. Both are equal, they said. Okay. And find the ratio of their volumes. Okay. So this is the R by L. This is R by L. Now what I need is volume sphere is 4 by 3 pi r cube. Volume of cube is L cube. So ratio of this one is nothing but this one. So yeah, I just need to do R by L whole cube. So that is 6 by 3 pi into square root of 6 by 3 pi. So this is the ratio of their. I can still simplify, but just left it like that. Okay. So you can find out the ratios like this. Okay. So let's see some examples before going into the exercise. Okay, a solid toy is in the form of right circular cylinder with hemispherical shape at one end, with hemispherical shape at one end, and a cone on the other end. Okay, so if you see the diagram, it is something like this. Okay, now the common diameter is 4.2 centimeters, and the height of the cylindrical and conical portions is 12 centimeters and 7 centimeters respectively. Find the volume of the solid. So since it's a volume question, you can, and it is nothing, it is just added extra, right? Each one is added to each other. Okay, not inserted into the other, right? So obviously, volume of the solid is sum of three individual volumes. Okay, just this is the formula. 1 by 3 pi r square h1 is the cone volume. Cylinder volume is pi r square h2. Hemisphere volume is 2 by 3 pi r cube. You just substitute the right numbers there, you will get the answer. Okay, this is the answer. Okay, next. A cylindrical container is filled with ice cream whose diameter is 12 centimeters and height is 15 centimeters. The whole ice cream is distributed to 10 children by filling in equal cones and forming hemispherical tops. If the height of the conical portion is twice the diameter of its base, find the diameter of the ice cream cone. Okay, so that's yeah given. So radius of the base of conical ice cream is around x centimeters. Let's call. Okay, diameter is 2x then. Correct. If x is the radius, then 2x is the diameter. Then height of the conical ice cream will be 4x. This is what is given. Correct. Now volume of the ice cream cone is volume of conical portion, but plus volume of hemispherical portion, right? So which is 1 by 3 pi r square h and 2 by 3 pi r cube. So if I substitute the values, r is nothing but x, okay, and height is 4x. If I substitute it, what I will get is 6 pi x cube by 3, which is nothing but 2 pi x cube centimeter cube. Okay. Now it is given diameter of the cylindrical container is 12 centimeters. Its height is 15 centimeters, which means volume of the cylindrical container is pi r square h, which is 540 pi centimeter cube. Now these two are equal because 10 ice creams are distributed from this, correct? So volume of cylindrical container divided by volume of one ice cream cone is 10. So if you put this one, you can get x value. X is 20, x cube is 27, so x is 3. Okay, x is nothing but a radius. So diameter of the ice cream cone is 6 centimeters. Okay, so this is how we calculate various problems in mensuration. Okay, next example. A solid consisting of right circular cone standing on a hemisphere. Right circular cone, okay, right circular cone, this one standing on a hemisphere here, okay, okay, is placed upright in a right circular cylinder full of water. Okay, this is immersed in a cylinder filled with water. It is this solid is immersed. Okay, now touching the bottom as shown in the adjacent figure. Okay, right. Find the volume of the water left in the cylinder. Given the radius of the cylinder is 3 centimeters and its height is 6 centimeters. Okay. So this solid object, when it is immersed in water, it will displace equal volume of the water. Correct. And so first thing is we calculate the volume of the cylinder, subtract the volume of this solid. Okay, because this much water will flow out, right? So volume of the cylinder we calculate here, volume of the hemisphere we calculate here, volume of the cone we calculate here. So volume of the solid figure is basically sum of these hemisphere and cone, right? That is here. And then volume of the water left in the cylinder is volume of the cylinder minus volume of the solid figure. Okay, so you substitute the proper numbers, then you will get answer. Okay, this is answer. Next example. A cylindrical pencil is sharpened to produce a perfect cone at one end, like this, right? With no overall loss to its length. Length is same, but it has become cone at one end. Okay. The diameter of the pencil is 1 centimeter and length of the conical portion is 2 centimeters. Okay. Calculate the volume of the peel that are obtained after sharpening the pencil. So that is nothing but initially this was the cylinder, correct? Initially it was a cylinder. So from cylinder we are removing the chopping the cone volume out, correct? So diameter of the pencil is 1, so radius is 0.5. Length of the conical portion is 2 centimeters, which remains same. Volume of peels is volume of cylinder of length 2 centimeters and base radius 0.5 centimeters minus volume of the cone formed by this cylinder. So which is nothing but pi r square h minus 1 by 3 pi r square h. Okay. So if I substitute the values correctly, then what I will get is 1.05 centimeter cube. Okay, this much wood or pencil is chopped off, basically peeled off. Okay, let's do exercise 10.3 now. A iron pillar consists of cylindrical portions of 2.8 meters height and 20 centimeters diameter and a cone of 42 centimeters height surmounting it. Find the weight of the pillar if 1 centimeter cube of iron weighs 7.5 grams. Okay. Volume of iron pillar is volume of cylinder plus volume of cone. Okay. Okay. So which is volume of cylinder is nothing but pi r square h. Capital H I am differentiating between the heights of cylinder and the cone. And volume of the cone is 1/3 of pi r square h. Okay. So if I take pi r square common, this is what the remaining here, right? So 2.8 meters is nothing but 280 centimeters. I just converted everything into centimeters. I told you before in mensuration where you can go wrong is one of the main reasons is units conversion. Okay. So you have to look at the units properly and convert them into single unit. Okay. So if I calculate this is 29,400 pi centimeter cube is what I will get. Okay. That's the volume of the iron pillar. So weight of 1 centimeter cube of iron, 1 cc of iron is 7.5 grams. So what about this much? Okay. Let's say 29,400 into pi into 7.5, which is nothing but uh, 69 6 lakhs 93,000 grams or 693 kgs. Okay. This is how this is the application, real application of mensuration, right? Calculate the mass, volume, and then volume into mass is volume into unit mass is basically density. That is, unit mass is nothing but density. Volume into density is weight, mass or weight or mass basically. Toy is made in the form of hemisphere surmounted by a right cone whose circular base is joined with the plane surface of the hemisphere. Okay, this is how the toy is made. Okay, hemisphere and on top of that a cone structure. Okay, radius of the base of the cone is 7 centimeters and its volume is 3 by 2 of the hemisphere. Calculate the height of the cone and surface area of the toy. Okay, so that's easy. Radius of the cone and hemisphere is 7 centimeters. Volume of cone is equal to 3 by 2 of volume of hemisphere. So if I substitute the uh, formula here, 1/3 of pi r square h is 3 by 2 of 2 by 3 pi r cube. Okay, 3 by 2 and 2 by 3 gets cancelled, which means h is equal to 3r, that is 21 centimeters. So height of the cone, okay, which is asked here, height of the cone is 21 centimeters. Now next, surface area of the toy. Surface area of the toy is curved surface area of cone plus curved surface area of hemisphere, okay, which is equal to pi rl plus 2 pi r square. Okay, pi r is common. L is nothing but square root of r square plus h square plus 2r. So if I substitute the values, r is 7, h is 21, okay, r is 7. If I substitute these values, what I will get is 794.86. This is the centimeter square of surface area of the toy. This is the surface area of the toy. Okay. Next, find the volume of largest right circular cone that can be cut out of cube whose edge is 7 centimeters. Okay. Yeah, this looks easy. If cone is cut out of the cube, cone base diameter equal to edge of the cone base diameter is edge of the cube. Okay, which is 7 centimeters. So radius is and height of the cone also 7 centimeters. Okay, radius is 3.5, height is 7. Now volume of the cone will be 1 by 3 pi r square h, 1 by 3 into 22 by 7 into 3.5 into 3.5, which is r into 7 height. So you will get 89.83 centimeter cube. This is the volume. Okay, next. A cylindrical mug of radius 5 centimeters and height 9.8 centimeters full of water. Okay, the mug is full of water. A solid in the form of a right circular cone mounted on a hemisphere is immersed into the mug. The radius of the hemisphere is 3.5 and height of the conical part is 5 centimeters. Find the volume of water left in the cup. I think exactly same problem was there in the example. Okay. Water displaced by solid is equal to volume of the solid. Okay. So this is the one you should know. So first calculate the volume of the solid, volume of the container, that is cylindrical mug, subtract them. Okay. So water left in the tub is volume of the cylindrical mug minus volume of the solid. Volume of the cylindrical mug is, it's a cylindrical structure, so pi r square h, so 770 centimeter cube. Volume of the solid is volume of cone plus volume of hemisphere, which is 1 by 3 pi r square h plus 2 by 3 pi r cube. If I put the right numbers, the value is 154 centimeter cube. So volume of water left in the mug is 770 minus 154, that is 616 cc. This much volume of water is left in the mug. Next. In the adjacent figure, the height of a solid cylinder is 10 centimeters and diameter is 7 centimeters. Two equal conical holes of radius 3 centimeters and 4 centimeters height, okay, of radius 3 centimeters and height 4 centimeters are cut off as shown in the figure like this. Okay. What is the volume of the remaining solid? Obviously, you removed some volume of conical structure. Since both are same, twice the volume of the conical structures you removed. So it's very simple. Volume of remaining solid equal to volume of cylinder minus twice the volume of cone. Volume of cylinder is pi r square h. Okay. So which is R is 7 by 2, H is 10. So you will get 385 centimeter cube. Volume of cone is 1 by 3 pi r square H. R is 3 and H is 4. So you will get 37.68 centimeter cube. Okay. Volume of remaining solid is 309.57 centimeter cube. Okay. Next. Spherical marbles of diameter 1.4 centimeters are dropped into a cylindrical beaker of diameter 7 centimeters. Okay, which contains some water. Find the number of marbles that should be dropped into the beaker so that water level rises by 5.6 centimeters. Okay. So here if you see, they did not give the height of the cylindrical beaker. That means we are assuming that water is not spilled out, water is just increase the level. Okay. So whatever is the increase in the height, that much is the cylindrical volume, right? Is the volume of the spherical marbles, number of marbles which are dropped. Okay. So simple. Diameter of the marble is 1.4 centimeters. So radius is 0.7 centimeters. Volume of one marble is this one 4 by 3 pi zero point 0.7 cube cc. Okay. Now volume of the initial water level, let's say, height of initial water level in the cylinder, let's say h centimeters, and the new level will be h plus 5.6 centimeters. So the difference in volume is nothing but 5.6 plus h minus h. So you'll get 5.6 pi r square. So that is this volume. Okay, this is the increase in the volume. Why this increase has happened? Why this much water level is increased? Only because of number of marbles put it into the water. How many number? Let's assume it is n number. Okay, so number of marbles needed for 5.6 increase in water level is equal to, okay, increase in water level volume divided by volume of one marble. Okay, so if I do this, I'll get around 150 marbles are required to increase the water level by 5.6 centimeters. Okay, next. A pen stand is made of wood in the shape of a cuboid, okay, with the three conical depressions to hold the pens, okay, like this. The dimensions of the cuboid are given here. The radius of each depression is 0.5 centimeters and depth is nothing but height of the conical depression, 1.4 centimeters. Find the volume of wood in the entire stand. Yeah, this is simple. First is cuboid volume, which is 525 cc, L into B into H. Radius of depression is 0.5 centimeters. Depth of depression is 1.4 centimeters. Okay. So volume of one depression is pi r square H, which is this value around 1.1. Okay. Okay. 1.1 cc. So volume of three depressions is 3.3 cc. So volume of the final pen stand is 525 minus 3.3, which is 521.7 cc. Okay. Hope you understand all these volume problems of different shapes, and how they are made, and what kind of calculations goes in. Okay. Conversion of one solid form into from one shape to another. Okay. So let's say example, you have a candle which is in a canonical structure, right? It's a cylindrical structure, sorry. Okay. Now once it is melted, it will go into different shape, right? So now, what kind of problems you can solve using this phenomena? Okay, let's see it. One is water from one cylindrical structure is poured into cube of either same diameter, different dimensions. Then how much water will get in? So into a canonical structure. So these kind of problems which we will know it. Okay. One example here is given, think and discussion. Which barrel shown in the adjacent figure can hold more water? Okay. So if the question comes when holding more water, that means it's a volume, right? Question of volume. So volume of this one is pi r square h. Okay. Pi is same. R square is 1 into 4. Okay. 1 into 4, which is 4 pi. What about the volume of this one? pi r square h, which is pi 2 square h, which is nothing but 4 pi, right? So these two structures, even though they look completely different, okay, both hold same volume of water, okay? So these are the kind of questions which we'll solve here. Let's see some examples first. A cone of height 24 centimeters and radius of 6 centimeters radius of base 6 centimeters is made up of modeling clay. Child molds it in the form of a sphere back. Okay, he takes this much mud and then molds it into a sphere. Find the radius of the sphere. Okay, this is an interesting question, right? So volume of cone is nothing but 1 by 3 pi r square h. Okay, now this has become a sphere of radius r, so which is 4 by 3 pi r cube. Same volume of mud is used, right? So 4 pi r cube equal to this value. So r cube is uh, this one and r is nothing but 6 centimeters. Okay. So these are the kind of problems we will solve in this. Okay. A copper rod of diameter 1 centimeter and length 8 centimeters is drawn into a wire of length 16 meters of uniform thickness. Find the thickness of the wire. So first one is copper rod is diameter 1, that is diameter 1 centimeters, length is 8 centimeters. So you find the volume of this one. Then second one is also in the form of a cylinder. So length of 18 meters and some R or some diameter, right? So again find the volume of this one. You can equate them, you will get the value. Okay. So these are all similar problems. Let's see the examples and then go to the exercise. Diameter of the internal and external surface of a hollow hemispherical shell are 6 centimeters and 10 centimeters. This is diameter. So radius is 5 centimeters and 3 centimeters. It is melted and recast into a solid cylinder of diameter 14 centimeters. Find the height of the cylinder. Okay. This is hollow, but this is solid. Okay. So even though it is hollow, you need to calculate the volume of only this one. So how do you calculate that? Okay. It's a hollow hemispherical shell. Okay. So outer volume minus inner volume, you subtract the inner volume, then you will get the remaining volume here. That is what equate to this cylinder volume. Correct? So outer radius of the hollow spherical shell is 5 centimeters. In the internal radius is 3 centimeters. Volume of hollow spherical shell is nothing but external minus internal volume, which is this value. Okay. Then since this is equal to this cylinder volume, okay, you equate it basically. Pi r square h equal to that value. Okay, 49. Equate both of them. You will get h. Okay, what is the height of the cylinder you will get? So height is nothing but 1.33 centimeters from this. Okay. Hemispherical bowl of internal radius 15 centimeters contains a liquid. The liquid is to be filled into cylindrical bottles of diameter 5 centimeters and height 6 centimeters. How many bottles are necessary to empty the bowl? Okay. First, volume of the hemisphere is 2 by 3 pi r cube and r is nothing but 15 centimeters. So this is the volume of the bowl. Okay. Liquid has to be filled into bottles. Okay. Of height 6 centimeters and radius is this one. So volume of one bottle is this one. Okay. Right. 75 by 2 pi cc. Okay. So now n number of bottles are required. So it is division of both of them. So we'll get around 60 bottles of volume is required to fill the bowl. Okay. The diameter of metallic sphere is 6 centimeters. It is melted and drawn into a long wire having a circular cross section of diameter zero point 0.2 centimeters. Find its length. Okay. Again, same problem. Conversion of volume. So first is spherical volume is nothing but volume of the sphere, which is nothing but for the metal used in a wire, it is cylindrical structure. So pi r square h equal to 4 by 3 pi r cube. Okay. With this, you will get h value. H is nothing but 36 meters. 36 meters of wire can be drawn from this sphere of 3 centimeters radius. Okay. How many spherical balls can be made out of solid cube of lead whose edge measures 44 centimeters and each ball being 4 centimeters in diameter? Okay. First, calculate the cube volume. Okay. Cube volume is this is the cube volume, which is equal to n number of x number of spherical balls. Okay. So spherical ball volume is here. Okay. Okay. The value is this value into x. So you equate both of them. X number of spherical balls volume is equal to 44 cube. That is the cube volume. So if we equate, x is equal to 2541 spherical balls can be made from the cube. Okay. Next. A woman self-help group, Dwakra, is supplied a rectangular solid, cuboid shape, of wax block with the dimensions of 66, 42 and 21 centimeters to prepare a cylindrical candles each 4.2 centimeters in diameter and 2.8 centimeters height. Find the number of candles prepared using this solid. Okay, volume of the wax is LBH, okay, because it's in the form of a rectangular solid, right? That is this value. Okay. Radius of cylindrical candle is 2.1 centimeters, height is 2.8. So volume of one candle is this much. This is the volume of one candle. Okay. Now volume of x candles is x into this number, which is equal to the rectangular block, right? So x is equal to division of both of them. You will get 1500 candles out of this wax. Okay, 1500. These are the kind of problems which we'll solve in this mensuration. So let's do exercise 10.4. Okay, a metallic sphere of radius 4.2 centimeters is melted and recast into shape of cylinder of radius 6 centimeters. Find the height of the cylinder. Okay, we have seen the example problem already. Radius of sphere is 4.2. Okay, volume of sphere is 310.464 cc. Radius of cylinder is this one. Height is h, let's say. Then cylinder volume is pi r square h. Okay. So which is equal to 310,464. So h is height of the cylinder is around 2.74 centimeters. Okay. Next. Three metallic spheres of radii 6 centimeters, 8 centimeters, and 10 centimeters respectively are melted together to form a single solid sphere. Find the radius of the resulting sphere. Yeah, this is good. Radii of three spheres is this one. So volume of sphere is this is the okay. Volume of the sphere is actually 4 by 3 pi r cube. I did not take 4 by 3, but actually it doesn't matter because we are equating this to uh, bigger sphere where it is also actually I skipped there also, right? So volume of new sphere also 4 by 3 pi r cube. Okay. I made a mistake, but I'm explaining why this did not uh, create a problem in my final answer. Okay. So sum of three spheres is 4 by 3 pi r1 square plus r2 square plus r3 square, which is equal to this value. Okay. New volume of new sphere is 4 by 3 pi r cube, which is this value. So if you equate them, 4 by 3 gets cancelled anyway. And r is new r. New radius of the sphere is third root of 1728, which is 12 centimeters. Okay. So this is what I was talking. Unless until you do a mistake, mensuration, you can't go wrong. Okay. So this is one mistake I have done, and units is other thing which you should be very, very careful. Okay. Uh, if you can correct these small mistakes, I think mensuration you should get 100%. Okay. There is no way you can go wrong in this. Okay. Next. A 20-meter deep well of diameter 4 meters is dug, and the earth guard by digging is evenly spread out to form a rectangular platform of base 22 meters into 14 meters. Find the height of the platform. Okay, yeah, this is very simple. First one is a cylindrical structure, correct? So volume of the mud removed is pi r square h. This is the volume of the mud removed. And the rectangular platform height is, let's say, h. Then length is 22. Breadth is 14. So volume of this one is 22 into 14 into h, which is equal to 770. It is made from this mud only, right? 770 meter cube mud. So from this h is equal to 2.5 meters. Next. A well of diameter 14 meters is dug 15 meters deep. The earth taken out of it has been spread evenly to form a circular embankment all around the well of width 7 meters. Find the height of the embankment. Okay. So this is what embankment I am talking about. Embankment looks like this. Okay. The well is below ground. Okay. But the radius of the well will coincide with the inner radius of this embankment, right? So if the radius of the diameter of the well is 14 meters, the inner embankment diameter also 14 meters. Okay, that you remember. And width is 7 meters. Okay, so the outer one is 7 plus 14 by 2, 7. 7 plus 7, 14. Okay, so let's see. Height of the well is 15 meters, radius of the well is 7 meters. Okay, volume of the mud dug is pi r square h, which is this value. Okay, volume of the embankment is cylinder volume with outer radius minus volume with the inner radius. Okay, so volume of embankment is pi h, pi into h. R is outer one is r plus 7 square minus pi h r square. Okay, so this is the value 22 by h into r plus 7 square minus r square. Now we know that r is 7, so it will be 14 square minus 7 square. So what I will get h is height of this one is 5. Okay, because I am equating this one and this one I am equating. R is nothing but 7. Okay, so h is the height of the embankment is 5 meters. Okay, next. A container shaped a right circular cylinder having a diameter of 12 centimeters and height is 15 centimeters is full of ice cream. Okay, it is in a right circular cylinder full of ice cream. The ice cream is to be filled into cones of height 12 centimeters and diameter of 6 centimeters, making a hemispherical shape at the top. Find the number of such cones which can be filled with the ice cream. Okay, you know the ice cream shape and the container shape now. So volume of cylindrical container is this one. Okay, pi r square h is the value, which is distributed into n number of cones with a hemisphere on top. Okay, so volume of the ice cream in a single cone is 1 by 3 pi r square h plus 2 by 3 pi r cube. Okay, so this is the value of one ice cream. Okay, so now for n number of ice creams, n into this value is equal to the container volume. Correct? So n is nothing but 10 you will get if you calculate. Okay, next. How many silver coins, 1.75 centimeters in diameter and thickness 2 mm, needed to be melted into form a cuboid of dimensions? This one. Okay. So simple cuboid dimensions are given, so you know how much volume is required, right? Volume of cuboid is L into B into H, which is this value. Okay. Volume of single silver coin is pi r square H. Okay. Here it is 2 mm, so it is nothing but the two diameter, right? Sorry, height. Height is 0.2 mm, which means it is sorry 2 mm, which is 0.2 centimeters. Okay, and diameter is 1.7 centimeters, so which is 1.752 is radius. Okay, so now n into this value is equal to this total volume of the cuboid. So with this I will get n is equal to 400. So 400 coins are needed to make the required cuboid. Next, a vessel is in the form of an inverted cone. Its height is 8 centimeters and the radius of its top is 5 centimeters. It is filled with water up to the rim. When a lead shots, each of which is a sphere of radius 0.5 centimeters are dropped into the vessel, one fourth of the water flows out. Okay, find the number of lead shots dropped into the vessel. Okay, this problem also we have seen similar in the examples. One fourth of the volume of flown out, right? So first calculate the cone volume, then one fourth of it, this much is flown out. That is the volume of the lead shots. Okay, height of the cone given, volume of the cone is here. Okay, lead sphere radius is this much, 0.5 centimeters. So volume of one sphere is this one. Oh, sorry, this is not volume. This should be 4 by 3 actually. Okay, this should be 4 by 3. Okay, the n number of lead shots needed for one fourth of water to spill out. So yeah, here I wrote correct actually, even though this is wrong actually. This should be okay, but here I wrote it correctly. Okay, n into 4 by 3 into 22 by 7 into 0.5 whole square equal to, sorry, this should be zero point 0.4 whole cube. I don't know, so many mistakes I have done. This is correct anyway, but I put zero point 0.5 whole cube only here. Okay, so which is equal to one fourth of water spilled out, right? So one fourth of 1 by 3 into 22 by 7 into 5 into 5 into 8. Okay, so n you will get 100. Okay, n you will get 100. The calculation somehow squares and cubes are wrong, but calculation is correct. Okay, it's 100. Next, a solid metallic sphere of diameter 28 centimeters is melted to recast into a number of smaller cones, each of diameter 4, 2 by 3, and the height is 3 centimeters. Find the number of cones formed. So same problem. Diameter of metallic sphere this much. So volume is 4 by 3 pi r cube. Okay, this is the value. Cone of diameter this much. So radius is 7 by 3, right? 14 by 3, it will become 7 by 3. Height is 3 centimeters. Volume of one cone is given here. Okay, one cone. So let there be n cones out of sphere, made out of sphere. So n into this value equal to sphere value volume. So from that we will get n value. Number of cones made is 672. Okay, next. Yeah, optional exercise. Let's do. A golf ball has a diameter equal to 4.1 centimeters. Its surface has 150 dimples, each of radius 2 mm. Okay, calculate the total surface area which is exposed to the surroundings. Okay, yeah, this is a good problem actually. All the dimples are like hemispherical. Okay, so first let us calculate volume of the dimple. Okay, and then volume of the surface area of the golf ball. Then subtract this. Okay, how much is the remaining volume basically? Uh, Remaining surface area, which is where there are no dimples. Okay, so let's see how to do this. Total surface area of the golf ball without dimples is 4 pi r square. Okay, this is the total surface area. Okay, careful. Okay, 4 pi r square. Okay, which is equal to this value 52.83 centimeter square. Total area where dimples are. Total area where dimples are is again pi r square. Correct. Okay, 22 by 7 into zero point 0.2. 150 hemispherical shapes are cut, right? So 150 uh, circles are cut basically. So this much area I'm touching on the ball, right? So pi r square into 150. This is 18.857 centimeter square. But this area has become okay, and this is the area where no dimples are. This area remains as is, correct? 152 minus 80, 52.83 minus 18.857. This will remain as is. Plus extra area will come. Area of dimples, that is. Area of dimples is 150 into 2 pi r square because this is hemispherical. Correct? So 150 into 2 into 22 by 7 into zero point 0.2 square, which is 37.714 extra area will come. Surface area exposed is area with no dimples plus area of dimples, right? So that is nothing but 71.687 centimeters square. So do this problem carefully. It's a very good problem, actually. Okay, next. A cylinder of radius 12 centimeters contains water to a depth of 20 centimeters. When a spherical iron ball is dropped into the cylinder, the level of water rises by 6.75 centimeters. Find the radius of the ball. Yeah, we have done this problem before. Water level of initial water level is H, so final water level is H plus 6.75 centimeters. The increase in water level is also in the shape of cylinder. So volume of increased water level is nothing but pi r square into H plus 6.75 minus H, which is pi r square into 6.75. Okay, this is the increase in water level, correct? Now, iron ball of radius, let's say r, is dropped into this. So, which is equal to 4 by 3 pi r cube, correct? It is dropped into this. Okay. So now radius of water container is 12 centimeters, radius of iron ball is r. So r cube is equal to around 3.6 you will get, which is nothing but 9 centimeters. Radius of iron ball is 9 centimeters. Next. Three metal cubes with edges given respectively are melted together and formed a single cube. Okay, yeah, this looks easy. Volume of three metal cubes is 15 cube plus 12 cube plus 9 cube. Okay, which is 5832. Okay, let the edge of the newly formed cube is a centimeters, then a cube equal to 5832, which is 18 cube. So edge of new cube is 18 centimeters. Okay, this is the edge. They asked diagonal. Diagonal is root 2 times the edge, right? So 25.45 is the diagonal. Next. Hemispherical bowl of internal diameter 36 centimeters contains a liquid. This liquid is to be filled in cylindrical bottles of radius 3 and height 6. How many bottles are required to empty bowl? Okay, yeah, we have again done this in the examples. Bowl is volume of bowl is hemispherical bowl is 2 by 3 pi r cube, which is uh, given there. Then volume of single cone is 1 by 3 pi r square h. So let's n number of cones are required. So n into 1 by 3 pi r square h equal to 2 by 3 pi r cube. If you substitute the values correctly, then n is equal to 216. Okay. So 216 canonical cones are required to empty the bowl. Next. Yeah, that's all. So this is all about mensuration. Very, very simple chapter. Remember the formula, and only extra thing you have to do is try to find out how to get that formula. Okay. If I say pi r square, 2 pi r h, 2 pi r h is the curved surface area of the cylinder. Okay. Visually see how that value has come. Okay. If you cut it basically and stretch it into a rectangular form, the length is 2 pi r and height is h. Okay. Breadth is height, which is h. So 2 pi r h it will come. Okay. So similarly for all of them, you find out how they have come so that you don't need to remember much. Okay. Don't do mistakes, and only two concepts are there. The total surface area of combined, if you add two solids, attach two solids, total surface area is not sum of those two solids, because some part will go off. Okay, but whereas volumes, if you attach two solids into a one, the volume is always combined of individual ones. Okay, remember this point. Thank you.